Do you work with a math section, that kind of it, or do you work with? Oh. Yeah, so I was talking about that, and I'm really excited, so that's probably I need to go. I need to go. No. I saw that portfolio. Okay, yes, checking that. What is? Okay. Sure. Yeah. What's interesting is like whenever you see your own working with the you have that code and I'm working and I'm doing this one. So there's a chance of fast reading that. Most of these young guys know when I think about furthering my education with college. 8 years ago, 9 years ago, like talk about articles and things that hasn't been the last 5 years like that. I talked about like
okay, let's go ahead and reconvene. It looks like our network glitch is passed. Yes, can you believe that? I was actually thinking we won't have internet for the rest of the week, you know, but I think it was simply a router that needed to reboot. Ironically, tomorrow's discussion is about the internet, and one of the big points that I wanted to get across is how the internet is designed to be scalable and reliable. So I may have to change my notes. Okay. There you go. There you go. It works just fine. You just can't get to it. All right. I'm not quite sure where we got disconnected. I know that we were talking about high level versus low level. So let me just summarize the big distinction. And what high and low refers to is how close it is to humans. So the human level is the high level because we're the ones who came up with the terms, and the computer level is the low level. And the closer what you say has to be like the way a computer thinks, then the lower level. Oh no! I got a warning. My internet connection is unstable. We may be down again shortly. We'll have to monitor. Who's not muted?
I wasn't, but I am now.
Okay. All right. Oh, amazing. Are we actually back on again?
We are.
Okay. Well, the remaining of the discussion is about 5 minutes. So let's see if we can make it in 3 before this thing goes down. Where is the share? Here we go. Okay. So the only thing I want to add about high versus low, besides what I've already said, is that it's easy to get confused and take that too literally. And for example, you can get a hardware chip that is a hardware chip. So of course it's low level, right? Except the hardware chip is doing something like digital signal processing. And so the way that you speak to it is by sending it an audio file and telling it to clean it, right? That's actually pretty close to a high level view because it's a human level task, you know, remove noise from sound recording, okay? Or it could be any one of really high level concepts, anything that you can write using a high level language, you can actually just turn into a chip, and then you have high level on a chip. So be careful of the distinction between computer level and human level quite that literally, okay? And I've seen the AP actually try to trick you with that, okay? Now, generally speaking, we want to use higher level languages, okay? Only a fool speaks to a computer in binary, unless that person is forced to speak to the computer in binary because that computer allows no other way, in which case that person gets paid a lot of money, okay? So we always want to use the highest level language possible, unless we're forced to use a lower level language. For example, if you want to write for a web application, so you're trying something that runs in a web browser, you're going to use JavaScript because that's what the web browsers use. Okay, so that happens. That's unavoidable. Okay, but other than that, you try to use as high level as you can get. Okay. By the way, here's another example of hardware doing very high level abstraction. I forgot about it, and that's a graphics processing unit. Okay, that's something that all of your students that like computer games know very well, right? And what does it do? It draws polygons, right? Drawing polygon is a very high level thing to do, right? As opposed to say drawing point or putting a pixel a certain color, but it's all done in hardware. Okay, that's all the College Board expects you to know about programming. It's actually remarkably little because the meat of it is in algorithms. Okay, so so you really end up getting the same kind of questions for both algorithms and programming. The big distinction is that when they do programming, they will explicitly use either a block-based language or a text-based language, and they give you the syntax for both of those ahead of time so you can become familiar with them. Okay, so you will see both. So even if you choose to use block-based, you will see text-based language questions. So you need to be able to at least read both. You're not necessarily programming both. Okay. When they do an algorithms only question, that's when they do the I have 10 students with 3x5 cards and they write a number and talk to each other type description. Okay. The multiple choice questions are going to be similar to the algorithms. You know, here's a maze, here's a robot and it's doing this. Okay. Except you see code. You see real, honest to goodness programming language code and said, go solve it. Okay. Now, the other thing that I've seen quite a bit of is a focus kind of in Boolean expressions. So they'll do a lot of if X is true and Y is false, what happens when you run this code? Okay. They may also write it in a slightly different way. Let's say that I have an if statement that uses X and Y and it prints 3. And so then they say, okay, so what must be true? Oh, what must be true is that X had to be false and Y had to be false. Otherwise, it would have printed 5 or 7 instead of 3. Okay, so that's another kind of question that they'll give you, and then there's the this is what X means. X means that the car door is open. Y means that the seatbelt is latched. Okay, and so this car will not start unless the doors are closed and the seatbelts are latched. What would you put in an if statement to make that happen? And they'll say if X and Y, if X or Y, if X and not Y, and so on. And then you have to say, no, it's actually not X and Y. And that's the right section, okay? The other set of code is they give you a function definition, okay? Like, for example, they might write a function definition called can turn left. And then they'll say, okay, so how can we use this function to achieve the following, right? So as part of a larger maze, you know, I want to be able to use this function to navigate. And here's a very simple example. If I give you the function max and the function min, then it says, how do you write a function that finds the range of a whole bunch of values? And of course, the answer is max minus min, but they want to make sure that you can do that. And that's what programming is, as opposed to algorithms, right? Again, the only difference is there's a programming language involved. Anyway, that's it for programming, okay? And remember, what we talked about today, about 40% of the written response test, that is 60% of the overall grade. So you're talking 24% of the total. This is the material here is really, really significant. Okay, and that's just in the multiple choice.
Hello, it's me.
Okay. That's actually not including the fact that the create task asked them to write a program, right? So, you know, the create task itself is about 20%. So overall, you're talking 44% of the total is right here. Okay. All right. Any questions? We can take them here or we can catch them in the chat. I don't see any questions. So I would suggest a break, but we just took one due to technological difficulties. But what I do suggest is that we spend the rest of the time just kind of trying to write those programs that are in WIO courses, okay? And you know the ones from units 1 and 2. I added some from unit 3. And as I said at the beginning of the class today, that is it, okay? So the programs that you see in WIO courses are the programs that we'll write for the rest of this week. And you can start getting to them. Oh, goodness.
Want to see?
No, you just gotta make a game, right? That's cool. Were those earlier they showed those symbols of mod and round? Is that how you get to some of the X's and the O's? So it doesn't just up to zero. I mean, they'll get it close with the mouse. And does it just put it into place? That's what I thought. Can we try to make it something instead of the X's and O's? It's harder. I'll have to come up with
Ruben,
Uh-huh.
this is Shirley Coulter. I just had a question. I'm
Yeah.
working on unit 2, but on lab 1, where we have all the code that they had us copy in and we run it, and it creates the circles and the pen is heavier in certain areas. The question I have is on 1, the 90 degrees is at the bottom of the circle. In other words, 0 is at the very bottom and 90 is in the lower left-hand quadrant. Whereas on another one, it appears that 90 degrees is towards the top. I'm trying to figure out, is that because of the go to X 0, Y 0s on one and not another? I mean, is this making sense? It's like,
I'm going to have to take a look at it. I'll bring it up.
okay.
I don't know off the top of my head, but my suspicion is that
Honeycomb, it was north.
it was north. Yeah. I mean, like I said, we humans have multiple conventions on what we mean by 0, 90, and so on.
Right.
The standard one that's used in Snap is the mathematician's viewpoint. No, I'm sorry. It's the navigator's viewpoint. That 0 is at the top and 90 is
Okay.
due east. That's kind of the way that they do it.
Now here's Jim. Jim has made a comment. He thinks that north is the direction in which your mouse is pointing. But when you recenter it, Jim, which way does it take?
Actually, that might be. Yeah, I think Jim actually nailed it, because in some of those labs, what's happening is you're going around in a circle, right? And as you're going in a circle, then you want to print different colors, right? So what the test is doing, some of the tests are doing, if the position is less than this, then blue, else green, right? You know, like the one where it follows the mouse is using the position. And the one where you're going around the circle, it'll use what direction am I pointing at. So if you're pointing in direction 0, it means you're pointing in direction east. And that happens when you're at the very top if you're going clockwise, and it happens at the very bottom if you're going counterclockwise, right? So it actually depends on how you go around the circle as well.
Okay, so let me understand correctly. The tip of the sprite, the tip of the point is 0
Yes.
on, okay.
No,
That
well,
makes better.
yeah, that's the 0 is actually always straight up. Okay, you know, that's 0 degrees. The question, and then it moves clockwise. So then the question is, which way is the sprite pointing? If it's pointing up, then it's 0. If it's pointing east, then it's 90. Okay. Right. And actually, I can try this.
See, I'm looking at the second one with the tip, and it's showing that 0. Let me see.
So
Okay, it's just the position of the pointer that's confusing, I guess. Okay.
yeah, remember there's a difference between position and pointer. So
Right.
let me try. I'm going to move by 1 step, and I'm going to turn by 1 degree. And then I'm going to say, I'm afraid that this is going to be a little bit too slow, okay? But
What I'd recommend, Ruben, and I don't know if you can, is if you look at Unit 2, Lab 1, that they have you open that's already done.
Yeah.
And maybe click on all 4 blocks and show everybody how, or I guess maybe I'm the only one that's trying to figure out the position of the 0, but it's between this middle 2 blocks that are somewhat confusing.
Yeah, I'm going to go there, okay?
And you're not the only one. It came up here at the end of last week. Just
Exactly.
FYI. It'll come up again.
What I wanted to try was this. This will have the turtle move around, and it's going to tell us what direction is on, okay? And is doing it very slowly because I'm having it step through so we can see the steps, okay? If I get rid of that, then it's actually moving faster, and you can see the direction that it's going in, right? Which actually has nothing to do with its location, right? So this will take 6 minutes to get all the way across, okay? But I'll interrupt it when we get to about here, because that's when it's going to change. Okay. So right here is that is pointing in this direction, right? And that's 235 because we start here at 0 and go all the way around to 180, and then what, 55 more? Uh-oh, I'm about to lose the internet, I think. Okay. So are these the ones that you're talking about?
Yes, and so let me look here. So it is the second one down on the left, go to X0, Y0, forever direction
one
less
here?
than 90. This one here.
Mhm.
And when you do that, when it shows, if I understand correctly, it says if it's less than 90,
Mhm.
it's in the upper left-hand quadrant, which I'm thinking it should be in the upper right-hand quadrant. So that's what I'm trying to figure out. What
Okay.
I'm,
So what I'm looking at is this. This is turning in this direction, right?
right.
So it's going to build a circle,
Right.
and wherever it starts is basically going to be at the top. Okay, and then build a circle like this, completely.
Correct.
Okay. So now when is it pointing in a direction less than 90 degrees? When it's coming down like this, right? Is
Mhm.
actually more than 90.
Exactly. And it's
Right.
going, but it's not doing that. That's what it's actually in the, like if you had your 4 quadrants, it's in the upper left-hand quadrant. That's what and maybe something's wrong on mine.
Okay, let's like I said, I'm going to go ahead and code this up here real fast.
Thank you.
May get into trouble because I don't know how long my internet's up, but
Okay.
we'll see. Okay.
Yes. Oh, sorry.
Ah. Okay, so the first thing that we want to observe is, remember when we said that he was always going to build a circle starting at the top and coming all the way down?
Yes.
It's false, right? That's only true when you start at the standard position for the turtle, which is in the 0, 0. Actually, and that's not really what matters. What matters is that it's pointing in direction east. Okay, so if it's pointing in direction east, right, then that's the direction. That's when it will build a circle going like that. Okay, now let's look at what happens here. You can see which way it's moving, right? It is moving like this, so it's actually going in a clockwise direction. So if it's going in a clockwise direction, it's going to be pointing straight up at this point. Agreed? Right?
Yes.
And straight up is 0. Okay? And then it'll increment 0, 1, 2, 3, all the way until it gets to
90.
this position, which is 90. So here is when it is less than 90. Okay? And that's why it is that upper quadrant. The answer to your question is because it's going clockwise. Okay? So when it's going clockwise, and that upper left is precisely when it is less than 90 degrees direction-wise, okay? So now let me stop it. I'm going to take this same code, okay, but I'm going to duplicate it. Put it here. I'm going to do a couple of things. First, I'm going to take the 0, 0, 1, 2, 3, all the way until it gets to this position, which is 90. This position, which is 90. So here is when it is less than 90 degrees direction-wise, okay? So now let me stop it. I'm going to take this same code, okay, but I'm going to duplicate it. Put it here. I'm going to take the I'm going to put the pen down there, but I'm going to put it up before it moves because that was kind of painful. Right, it drew that line for us. Don't want that, okay? And the other thing I'm going to do is I'm going to have a point, okay? So here, I'll have a point in direction 90. And on this one, I'm going to have a point in direction 270, okay? Or I guess minus 90 left, okay? That works too. Okay, so let's run this version. I'm still going clockwise, okay? All right, this is the one that actually does draw it underneath me, right? But it's drawing it clockwise, okay? And so again, this is the area that is between 0 and 90, okay? Now let me stop that. Let me turn in the other direction. Oops, stop that. Okay. Okay, and see what happens. Okay, so now I'm going, I need to reset the state of the pen each time. Okay, that one puzzles me because direction should not be. Here's a trick. You can actually see what the direction. Oh, I see. I'm doing negative degrees. Okay. You know, so setting it to minus 90 was not wise. Okay. So, so anyway, a couple of things with this. They're really careful about what they give you. Okay. So that's what they gave you this example where it, oh, I've got my turtle totally confused now. But,
So again, when the arrow, no matter what, even on the, in that upper quadrant, when that faces north, that starts 0.
that is 0. Yeah.
Okay, that makes better sense.
Yeah.
Even though it's starting, yeah, and if it's not starting at 0 is irrelevant, just when it's pointing up.
Exactly. Exactly.
Okay.
Right.
Thank you for that clarification.
And it's worse than that. I'm afraid, just because of you know, these are degrees, so you're going around a circle, right? The position in here is minus 90, so so it's actually changing what it considers to be less than 90. You know, minus 10 is less than 90. That's unfortunate. We could put here between 0 and 90, and that would work better. Okay, so so that's something that happily works.
Okay.
Like so. But yeah, and the intent of the guys who wrote those is just to give you a starting place and have you, you know, experiment. That's really how you learn this stuff.
Can anyone tell me what the difference is between the mouse X, mouse Y, and 0, 0?
I think mouse X and mouse Y is actually the current position of the mouse. And I don't know what you mean by n 0, 0.
Like, for example, again, I'm on those same scripts. At the very top, one says go to X, and then you put in mouse X, and Y is mouse Y. You drag those two in.
Right.
Whereas what we've been using is go to X and you put in 0, 0. When you click those two, they're different. Yeah, they're different.
Okay. I'm looking for the, there we go. Here they are. Okay. So mouse X is actually the current position of the mouse. Okay. And so you can see them here, right? And you can see that as I move the mouse, okay, they actually change. Okay. On the other hand, let me move this out of the way. On the other hand, the turtle can move, and that doesn't make it change, right? Only this. So that's just a way of, for example, if I were here, then the turtle can sense me and actually turn towards me. That's the point of that. So when you say go to mouse X, mouse Y, the turtle would just jump to wherever I have the mouse set. If you say go to 0, 0, then it'll just go to the center of the screen, right? You know, so that's the difference between those.
Okay, I see. On the first script, it would always jump to the left with mouse X, mouse Y, but that's because our mouse is there? Okay, I'll check it again.
Exactly.
Thank you.
You can just move the mouse location.
Okay.
Okay, well, it says she's already in the course. But she's not in the course. Bless you. Does this make sense to you? Instructors already. So she's not in the course. It won't let me add her, and this is the description.
Okay, so who is it?
Lisa Johnson.